welcome everyone to the South Kohala Coastal Partnership Speaker Series. And I'm Lauren Krupita, the coordinator of the partnership. And the goal of this series is to provide an opportunity to learn more about the partners and work being done. And the catalyst that started this was the State Division of Aquatic Resources and the Coral Reef Working Group identified South Kohala as a priority area for the Hawaii Coral Reef Strategy to implement actions to reduce anthropogenic impacts to the reef. And in 2018, over 30 organizations and agencies participated in creating the South Kohala Conservation Action Plan 2030 that outlines 6 specific strategies to guide the partnership in collaborative work towards restoring and protecting our coastal resources. So today, for our speaker series, we are honored to have Dr. Elliot Parsons, who is a specialist at the University of Hawaii at Manoa with the Pacific Regional Invasive Species Climate Change Management Network. He works to facilitate a large network of managers, researchers, and community members interested in the intersection of climate change and invasive species across Hawaii and the US affiliated Pacific Islands, including Guam, Commonwealth of the Northern Mariana Islands, American Samoa, Palau, the Republic of the Marshall Islands, and the Federate States of Micronesia. Elliot received his doctorate in fish and wildlife biology at the University of Montana and his undergraduate degree in cultural anthropology at the University of California at Santa Cruz. Elliot served as the Pu'uwa'awa'a coordinator for the Hawaii DLNR Division of Forestry and Wildlife for 12 years before his new role with Pacific RISCC. And he has taught wildlife science courses at UH Hilo since 2016. His presentation is titled Exploring the Nexus of Climate Change and Invasive Species with the Pacific RISCC. And welcome, Dr. Elliot.
Thank you so much, Lauren. We share screen. Can you see the full screen or do you see presenter mode?
We see presenter mode.
Oh, presenter mode. Okay, shucks. Let me try something else then. 1 second. Just unplugged an external monitor. Okay, how about now?
Perfect.
Okay. Well, thanks so much, Lauren, for the invitation to speak with the South Kohala Coastal Partnership about invasive species and climate change and their interaction. My name is Elliot Parsons. Thanks so much for the introduction. And I'm calling in from the Ahupua'a of Hulualoa and the Moku of Kona on the island of Hawaii. And I'm excited to be here and share with all of you what we've been working on. And I'd like to start us off by just thanking our leadership team for Pacific RISCC. So the talk is Exploring the Nexus of Climate Change and Invasive Species with Pacific RISCC, which stands for the Pacific Regional Invasive Species and Climate Change Management Network. My position is based out of the University of Hawaii at Manoa. And we have a large group of people who are helping guide the direction of this large collaborative effort across the Pacific. So I'd like to start off by calling attention to the invasive species problem in Hawaii and also across the Pacific. This is just an image showing the comparative density of non-native species richness by geographic area. And you start off on the left with Alaska, and then the continental United States, and then you see the incredible density of dots, just showing how many invasive species and how dense our invasive species are in Hawaii as compared to elsewhere. And this presents a lot of problems. These problems span native biodiversity, and including causing extinctions and threatening with extinction many native and endemic species in the islands. Invasive species threaten agroforestry systems and food security, marine environments, riparian areas, agriculture, sustainable livelihoods, traditional and cultural practices, groundwater and soil health, and pretty much every aspect of the human and natural environments in Hawaii. And in fact, a recent study that we're reviewing right now for Pacific RISCC to share out with our network looked at the relationship or the context of biological invasions as compared with natural disasters. And so natural disasters, most folks are familiar with earthquakes and floods and drought and wildfire. And this study looked at changes over time in the damage costs, so economic losses of invasive species. And this graph is looking at it worldwide. And you see the BI right there in red, which is biological invasions, showing that the cost of biological invasions worldwide has increased significantly and now rivals many other natural disasters. And right now it's second to the impact from storms. And focusing in a little bit more towards the United States and the Pacific region, they broke down the costs between 1980 and 1999. So those are the darker parts of the bars in the bar graph on the left. This is North America. And then the lighter part, the last couple decades, this is looking across a 40-year period. And they found that biological invasions were the second costliest natural hazard after storms. But when we look at Oceania and the Pacific Islands, the biological invasions are now taking a front seat and in fact are more costly than all the other natural hazards combined. And that rate of increase has increased significantly. So you can see that bar was pretty small with the dark colored red, 1980 to 1999, but it has grown significantly in the last couple decades. So biological invasions, the costs are increasing through time and are comparable to natural disasters that we see worldwide. And to focus in a little bit on conservation, we know that invasive species in the Pacific Islands are driving the conservation crisis. They're causing species extinctions. This is the brown tree snake in the upper middle, which has caused the extinctions of many of the native birds on the island of Guam, US territory of Guam. We see the coconut rhinoceros beetle, which is having a huge impact on coconut palms, feral ungulates, little fire ants, and those are having huge impacts on native species, causing population declines. And that the number of non-native species that are showing up and getting established are increasing through time as well. So this is some recent work by Kelsey Brock and Kurt Gaylor, and they looked at the arrival date of different non-native plants in Hawaii from 1900 to 2020. And you can see it's a fairly linear line from the left side of the graph, Hawaii becomes US territory, up to the present. And you can also see where noxious weed rules were implemented, where weed risk assessments were implemented, where the interagency biosecurity plan was started, and that rate is still going up despite those advances. And in fact, to put a number on it, the average rate is actually about 12 species that are of plant that are being naturalized or are establishing on their own in Hawaii every year. And that rate has likely increased since the 1980s. So invasive species have detrimental impacts, and those impacts are likely going to get worse because the number of non-native species that are arriving and establishing is increasing. But invasive species aren't the only thing, of course, that we have to worry about. Climate change is becoming more of a critical threat to natural systems and human communities and human health and livelihoods. And we know there are a variety of impacts of a changing climate that are being seen, from increases in ocean temperature and acidification with consequences for coral, sea level rise, coastal flooding, erosion, saltwater intrusion, the effects of ecological drought. That picture in the upper right is Pu'uwa'awa'a back in the drought in 2010. Wildfires, which we've seen a couple of the largest wildfires in the state history in the last couple of years. Changes in rainfall, and then increased storm intensity and frequency across the Pacific. And not only are we seeing these impacts, but we're also seeing multiple combined events, multiple events that are combining, and that exacerbates impacts. And so there have been a variety of studies and reports kind of looking at these compound events under climate change. And, you know, some of the ones that are being witnessed: wind and precipitation, heat waves, and droughts are another couple. And just in the last couple of years, I know a number of managers who were greatly affected by those Kona low storms, which hit with wind following a different direction usually than it usually does, and knocking over thousands to tens of thousands of trees. And so the likelihood of these compound events is actually increasing as well. So how will climate change affect invasive species? And that's kind of where Pacific risk fits in, and what I want to focus in on today. And why should we care? Why should we worry about it? Well, one of the big reasons we should care is because we know that landscape scale invasive species management is very, very costly and must be strategic. A lot of the efforts across the island probably are considered heroic efforts by many in terms of how much resources, staff, time, funding are needed in order to make a dent. There are a lot of articles that have come out in the last few years drawing attention to this nexus of climate change and invasive species, and I'll just share a couple of them. So climate change drawing invasive species to the Arctic. Acadia National Park, invasive plant problems worsening with climate change, looking at the impacts on native trout species in the Rocky Mountain West. And an article in the Smithsonian Magazine, how climate change is helping invasive species take over. So, so this is out there. There are a lot of articles about it. People are really worried about it, and worried about it because there are a lot of different ways or mechanisms by which climate change could exacerbate invasive species issues. A meta-analysis, which is kind of like a study of studies. And so taking all the different studies you can find on a subject, combining those all together to see kind of overall, what does that tell you? And so this meta-analysis was done looking at how do climate change, invasive species, and their interaction impact ecosystems. The two colors, the dark blue in the top and the dark red in lower bottom, were cases of synergistic impacts. And so basically, there were cases in which climate change and invasions were either more detrimental, so that's the red, than you'd expect, just based on the two impacts alone, or were were not as bad as you'd expect. And in almost 30% of those cases, those interactions were synergistic, meaning that climate change and invasive species are combining in these unpredictable ways that may exacerbate or lessen the impact on ecosystems. So let's talk about the Pacific. How might climate change affect invasion processes in the Pacific region and in Hawaii? It's helpful to think about different stages of the invasion process. And so a lot of folks in the last few decades have recognized that species have to go through a number of steps or stages in order to go from their native range where they evolved to their new range where they're having impacts. And so this breaks down those stages into these 5 different boxes to make it easier for us to understand and talk about. And looking at the first one, transport. So invasive species have to be transported here, and climate change will likely open up new pathways, new transport routes or transport mechanisms, and that will increase the pressure we see from arriving organisms. That will increase the likelihood of establishment. In terms of introduction, increased storm frequency and severity can definitely increase the amount of disturbed areas where invasive species can establish that are already present, but it can also introduce new species. Looking at the establishment phase, we're going to see changes in climatic suitability. So perhaps increases in temperature, which could make areas more favorable for drought-tolerant invasive species, for example. And the increase in carbon dioxide in the environment has been shown to allow some plants to become more competitive. And that allows them potentially to respond more quickly to climate change as the native species might be able to. With a higher CO2, plants are able to reduce the size of their stomata, which means that, and that's where gas exchange happens, but it's also where water kind of leaks out into the environment. And so plants can become more efficient at using water with increases in CO2. And then finally getting to that last stage, the impact stage, these changes could lead to increases in abundance or density and therefore overall impact. And so that picture, of course, is strawberry guava, a strawberry guava thicket, which is so dense that it is hard to even walk through that. So some of the consequences of this intersection of climate change and invasive species on non-natives and invasives, changes in the distribution or changes in elevation, so species shifts, shifting invasion hotspots. So places that are hotspots for invasive species right now might shift in the future. In Hawaii, a lot of those areas are lowlands where the more montane areas are areas that don't have as many invasive species and aren't as impacted, but those hotspots of invasion can be shifting upslope with climate change. We talked about plants becoming more efficient with greater CO2 concentrations in the atmosphere, which could potentially reduce the effectiveness of herbicides, and there could be mismatches in terms of temperature or things like rainfall that reduce the effectiveness of biocontrol agents. And then a really big one is declining ecosystem resilience due to disturbances. And so we know climate change is going to be basically exacerbating all of these disturbances, such as more extreme wildfire, more extreme and numerous droughts, greater storm severity, and all of that reduces the resilience of these ecosystems, which may no longer be able to repel invaders in the future, especially as large spaces are kind of opened up. And I got a chance to see that in a music forest a few days ago, where walking through the music forest on Hawaii Island, you could see these big tree falls, and the tree falls came down during that Kona low storm last winter. And those tree fall gaps were just completely filled with non-native and invasive species. And so the chances of those happening more and more often with climate change are going to challenge our ability to manage ecosystems and maintain native species. To give a couple examples, especially given the recent storm. So in 2020, these reports called the PERCA reports were produced by a number of folks at UH and Pacific RISCC and other organizations, Fish and Wildlife Service, called the Pacific Islands Regional Climate Assessment. And they kind of focused in on different partners. And so this was the report done for Guam. And they highlighted that stronger tropical storms and typhoons are expected with higher wind speeds, more rainfall, and a greater potential for damage. And, you know, many things, of course, can be damaged. You know, of course, houses, people could lose their lives, infrastructure. Focusing on invasive species, one of the impacts that's been realized in the last decade plus has been coconut rhinoceros beetle. And so coconut rhinoceros beetle, it is relatively recent to Guam, discovered in 2007, and it has a devastating impact on coconut palms and has led to widespread mortality of coconut palms, which are really important cultural species. They provide, you know, food and nutrients. They're also, for some Pacific islands, such as the Republic of the Marshall Islands, a huge part of the national export, so a huge part of the economy. And on Guam, increasing storm intensity and frequency is resulting in the accumulation of green waste from all of this vegetation, which is the perfect breeding grounds for the coconut rhinoceros beetle. And so what is that nexus? So coconut palms and other potential hosts, such as their endangered cycads, damaged by storms, may be more vulnerable to coconut rhinoceros beetle. We already talked about populations increasing after storms of CRB. And then this is another big threat, and that's the loss of coconut trees is expected to increase coastal erosion of the shoreline, and combined with sea level rise will lead to increased shoreline destabilization with impacts that would be, you know, greater than expected without invasive species. And of course, we all know this, this really large typhoon, super typhoon, Lavar, hit Guam just a couple weeks ago, was the largest typhoon in the last couple decades to hit the US territory, and had huge impacts. And folks are really, you know, in addition to recovery efforts, are also worried about the spread of invasive species from that storm and what's that going to do to coconut palms and remaining native species. And you know, this brings up as well, I saw an article about relief efforts heading to Guam, that increased transport is really the mechanism for the spreading of invasive species. And so larger and more damaging storms may increase the need for relief and recovery aid, which could potentially bring in more invasive species in the future. And then just looking at, you know, a few more of these, and this is looking at Guam and the Mariana Islands. You know, there are species that exist on some islands, but not all islands, or in low abundance, but, you know, but some islands it's high. And so ones that potentially are going to be transported around, the Cuban slug, the brown tree snake, CRB, yellow crazy ant are all species that folks are really worried about. Focusing in just a little bit on how climate change may alter the distribution of existing invasive species, because that's a really big concern as well. There are a couple different ways. Higher temperatures, milder winters will increase the survival and reproduction of invasive species that are limited by temperature. So for Hawaii, what that means is a lot of species shifting upslope as temperatures increase. Dispersal traits allow existing invasive species to expand their ranges into newly suitable habitat more quickly than native species. A lot of invasives have traits that kind of allow for that. They can respond quickly. They have high reproductive rates. They're wind dispersed or have fruits that are dispersed by birds, for example. Species are expected to shift towards the poles or up in elevation or even to deeper depths, for example, in marine environments, to stay within their preferred climate range or climate niche. And that's so that they can, for example, theoretically optimize their temperature and then kind of track that preferred niche or place in the ecosystem. So what is our evidence on species shifts? It's really interesting. There's been some really good work on it the last couple of years. This article used what they created, which is called the BioShifts database, and they found evidence for 30,000 range shifts of species from 258 studies for almost 12,000 species. And if you look at that horizontal axis on the bottom, the velocity of range shifts, so the 0 is the equator, and then as you go to the left or the right, you're going towards one pole. Oh, sorry, I'm misreading that graph. On the right side of that 0, you're going towards the poles, and on the left side, you're moving towards the equator. And then on the right graph, on the left side of that 0, you're moving downslope in elevation, and on the right side, you're moving upslope in elevation. And so the key takeaway from this study is that a lot of range shifts are happening across many species. A lot of those are shifting towards the poles because you can see a lot of the midpoints for a lot of those different taxonomic groups are to the right of that 0 line. And then similarly, there are a lot of taxonomic groups that are shifting upslope in elevation. And then this is just one more study I wanted to point out, which also has some interesting implications. So this was an incredible effort, a meta-analysis, sorry, not quite a meta-analysis, more like a systematic review study of species range shifts. And they wanted to ask the question, are species shifting in what's predicted with climate change? So following their climate range or niche as temperature increases. So, and the prediction is towards the poles, up in elevation, or to deeper depths. They also assessed a huge number of articles, narrowed that down to ones that fit their very strict criteria, and they found about 32,000 range shifts across 12,000 species. But the big takeaway from this study was that less than half of the species shifted according to expectations. So that means there are a lot of species that are shifting the opposite in terms of the direction that's expected, downslope in elevation, shallower depths, or towards the equator. And this is significant because most of what we know about how climate change may affect invasive species distributions in the future is based on climate models that project out those changes in temperature. So a lot of those models are called climate niche models, climate envelope models, and you're assuming that temperature is really the main driving force behind those species shifts. And so I just wanted to point out one study that we highlighted for the Pacific RISCC and shared this out with our network, and it looked at this invasive vine. And you see the state of Hawaii, so the historical distribution of where the species is located is found in the red. And then they looked at 4 different climate scenarios to basically show that distribution is expected to increase in Hawaii in the future with much more highly suitable areas available. And so you might look at this and you might say, well, this species is going to become a much bigger issue in the future with much larger impacts, and that may be true, but the previous study also says that species shift for all kinds of reasons, most likely, and it's not just temperature, but things such as the context of the community are important, rainfall is important, predators, competitors, human anthropogenic impacts, land use, all of those are going to affect where species shift and what species become issues. So one of my big takeaways from looking into this the last year plus is that a lot more research is needed. We really don't have as much information as we need about how climate change will impact invasive species, especially as compared to other areas of the world. But given these likely changing impacts, how are we going to chart our course in the future? So the Pacific RISCC, to introduce this organization that I'm part of, was initiated in 2019, expanded in 2021 and 2022, and includes a leadership team with folks from across all the U.S. affiliated Pacific Islands and different organizations and agencies in Hawaii. And this is our area, and it's a huge area to be looking into this intersection for, because it includes an area that is much, much larger than the continental United States when you're including the ocean. It includes over 2,000 islands, over 20 different languages. And so it's a really diverse area with a diversity of challenges and issues, but all united in Pacific RISCC because of this interest in how climate change may affect invasive species in this region. Pacific RISCC isn't the only RISCC, so there are a network of RISCC groups throughout the United States, and this just shows you where some of them are. The first one is in the northeastern United States, Northwest and Pacific RISCC started up, and then North Central and Southeast have followed. And so these ideas of trying to create these networks to look at this is caught fire, so to speak, and is spreading. And so what do we do? What do the RISCs do? The biggest things are to try to bridge historically separate disciplines or networks. Folks working in invasive species and climate change haven't always talked to each other. They haven't always gone to each other's conferences or meetings or shared work or research. Also, we hope to focus attention on all of the research needs that are out there and connect managers that need research with the researchers who might be able to do that work, as well as take the existing work that has been done and try to share that out with the network in a way that's easily understandable, easily digestible. And so that's part of the translational work that we do, translating science into management implications or considerations or on-the-ground actions that can be done. Pacific RISCC, led by Dr. Laura Brewington, produced this survey where they asked folks across the Pacific, although most of the folks who responded were from Hawaii, what they desired. And a lot of folks wanted to have climate projections at appropriate scales, which are small scales, the scale of islands, collaborative research projects, better communication, and a better understanding of uncertainty were a few of those. And so we're trying to fill some of these desires through Pacific RISCC. We have a listserv that I can add you to if you're interested, where we share out information. We have a webinar series. So these are some of the ones that we did last year, focusing in on how climate change may affect invasive species, what the impacts are on fire, on native species, for example, on watersheds. These are a couple of our more recent webinars. So in April, we looked at changing climate and wildfire in Hawaii with folks from Hawaii DO and Aradofa. and UH Extension. And then this last month, we had a webinar focused on how can you take all of this information about climate change and invasive species and then use that information to prioritize the conservation of US seabirds, many of which are in real big trouble, having seen declines of more than 90% in the last few years. And then one of our upcoming webinar, which we're really excited about for this month, and I'll put a link in the chat after we finish if you're interested, is going to be on how Hawaiian anchoring ecosystems and fish ponds may be able to think about and adapt to climate change in the face of both climate change and invasive species. And we're going to have folks working from a variety of different places telling us what they're up to and why, and how they hope to conserve these really important areas and ecosystems in the future. We're creating what we call manager research summaries. And so these are some of our translational products. We take a peer-reviewed paper, which may or may not be accessible to the public. And we really think hard about that article, digest it, and then summarize it with management considerations and take-home points. And we send that out to our network of folks so that they can basically find out what are some of those top take-home points without having to read the whole article and even pay, anywhere from $20 to $30 to get it. We're also just starting to develop what has been called across the National Risk Group Management Challenges, and those are syntheses of a topic. And so we're going to try to finish in the next couple months a synthesis of some of the top interactions of climate change and invasive species across the US Pacific, and put that into a easy to share, easy to understand 2-page document. As part of that, we're conducting a literature review of what's been published recently, the last couple decades on this in the Pacific. And we found, a lot of articles with a lot of different conclusions. So range expansion of invasive species has been found as an expected consequence of climate change across many different studies and many different taxonomic groups, from invasive bees, fruit flies, mosquitoes, frogs, snails, plants, fish, green algae. But others have also found range contractions, so invasive species that may be less of an issue to deal with in the future, such as certain plants, and then multiple invasive taxa on low-lying islands that are expected to disappear with sea level rise. One of the largest stories over the last couple decades has been the one with mosquitoes carrying avian malaria and avian pox, which is fatal to a lot of native and endemic forest birds in Hawaii. Increasing temperatures are causing these invasive mosquitoes to shift upslope. And these areas that used to be safe refuges from malaria are now starting to see mosquitoes more and more often and even year-round. And a lot of these forest birds are really not adapted at all. Some studies have been done, before when certain Hawaiian honey creepers were a lot more common. Studies were done where they challenged those species after catching some individuals and found that the mortality rate was almost 100%. These 4 species in particular, the kikiki, the KKA on Kauai, the kiwikiu or the Maui parrotbill, and the kohe are all projected to go extinct in the wild in the next 10 years because of these shifting mosquitoes due to climate change. I'll just share a couple more things, and I'll be interested to hear questions and what you all are interested in learning more about. This was a study done by some modelers modeling the invasive, the projected change in plant invasions in Hawaii with different climate scenarios. And what they found in general is that we can expect the invasion pressure to increase a lot in Hawaii's upper elevation areas. And then another study as well that came out in 2018 that I think is a really good big picture study to share out and try to get the word out. And this was by Lucas Fortini and Jim Jacoby, and they broke the different biomes in Hawaii. So kind of like the plant community, the very general plant community types into just 4 general categories. Dry shrubland, dry forest, mesic forest, and wet forest. And so some of the big changes are due to precipitation. So precipitation has a big impact on kind of what kind of biome or general plant community you expect to see. And they found pretty large shifts with climate change. And on the right side, what they wanted to do is they wanted to ask the question, what areas are not expected to shift? So basically, if you look across all the different climate scenarios, which we don't have that many in Hawaii, unfortunately, but they kind of have different predictions of how rainfall and temperature are going to change in the future. So across all of those climate scenarios, what areas are not projected to change? So what areas will be robust no matter what scenario we look at? And those areas are on the map on the right. And so basically the areas that seem to be, relatively safe in terms of biome shifting are wet forests in the Kohala Mountains, the upper elevations, and then some on the Hilo side with a smattering of mesic forest on the leeward side. The areas that are in white are expecting to see shifts primarily from mesic forest to dry forest, and then from dry forest to dry shrubland. And then with dry forest not really changing, because even though it's losing area to dry shrubland, it's also gaining a lot of area as mesic forest basically becomes too dry to be mesic anymore. So there are huge implications for both native and invasive species. And so to wrap up for the Pacific region, what, based on all these different articles, what we know, what we don't know, what can we expect now for the Pacific? Right now, we expect that climate change is going to increase the movement, the establishment, and the spread of both new and existing invasive species. It's going to probably exacerbate wildfire, invasive species issues due to changes in wildfire, drought, and storm severity, which is going to reduce the resilience of ecosystems, making them more prone to invasions in the future. We can expect increases in disease due to warmer temperatures. We can expect warmer conditions, more acidic oceans, which is going to reduce the resilience of coral reef ecosystems and their ability to buffer storms, which is a really important ecosystem benefit to human communities, as well as reduced water availability with impacts to human communities and native species. So those are all takeaways at the moment without going into more detail, since we have an incredible amount of uncertainty. We can't predict the future, which a lot of that is based on how humans deal with emissions and how good humans are at reducing emissions. So I want to try to end on some kind of a happy note, because a lot of this is, can be heavy to take. And so this was an article done quite a few years ago now, 2009, and it kind of, flipped it on its head and it say, well, we can think about this as providing restoration opportunities for the future. So we really need to be thinking about, changing our mindset and starting to think in a climate change context of, species are going to shift, and that's going to, potentially create opportunities for establishing plant communities that we think will benefit both humans and nature. As well, there's some really amazing growing collaborative efforts across the Pacific. This was the first meeting of the Pacific Ecological Security Conference that happened last year with a large number of participants from over 14 Pacific Island countries and territories. A lot of high-level delegations were there. And they realized that we can't really, control all invasive species. We kind of have to focus our effort. And so some of the most important areas for collaboration and future investment were identified as invasive ants, coconut rhinoceros beetle, and increasing biological control facilities and support. And so those are three of the main rallying cries right now of groups across the Pacific to coalesce around and try to make a difference. As well, at this meeting, participants confirmed that invasive species are a major threat to maintaining the resilience and adaptability of Pacific Island ecosystems, as well as food security, biodiversity, sustainable livelihoods, and the protection of traditions and cultural resources. So it's many different things that we're wanting to protect here. And they express this collective awareness and need for coordination to address these specific issues and the need for a Pacific-wide initiative. And so I just would like to invite all of you to join us if you're interested in any of these issues. Please join us. We're interested in prioritizing and promoting relevant research, assessing management needs, and trying to get what managers need and get those research needs filled by those who can perform that research. Develop successful management strategies for dealing with these changes. Coming up with better information sharing strategies. How can we get the word out? And how can we expand consideration of invasive species concerns in climate policies, as well as climate issues and biosecurity planning? And I routinely review new climate action plans that don't mention invasive species, or invasive species plans that don't mention climate change, but they really need to be integrated. And there's now a couple of decades of really strong research indicating that it's crucial that we integrate those things in the future if we're going to have a chance at making a dent and maintaining the well-being of the human communities in the Pacific, as well as the native and endemic diversity that is just so important for quality of life and cultural traditions. So please join our growing community of practice. Get in touch. Let me know if you have any questions, if you have any observations about both climate impacts as well as invasive species or their interactions. I'd love to know about it. And please join our listserv to find out more as we share out this information in the future. And a huge mahalo again to Lauren for the invitation and the South Kohala Coastal Partnership. And with that, I'm going to stop sharing.
Thanks so much, Elliot. We did have a question in the chat. If you knew anything about the process of harbor security at Kauai High or any of our harbors in Hawaii.
So I'm not directly involved in harbor security, but I can connect, who's ever interested in that with a bunch of folks that are working on those issues. We have a great program through Division of Forestry Wildlife and the Hawaii Invasive Species Council that includes the ports, that is funded and has a couple of people involved in that effort. So I'm happy to connect anybody with those folks.
Great. Did anybody else have any questions?
Yeah, thank you very much for that presentation. It's very humbling, and I'm keen to read that article on restoration opportunities ahead. I was kind of curious what your perspectives are on how restoration efforts in Hawaii might change going forward in light of this topic.
Sure, it's a huge question, and I think we could have a whole webinar series dedicated to that, which is maybe a good idea since so many people are working on restoration in Hawaii and across the Pacific. So, you know, if I wanted to kind of repeat that question and maybe reframe it just a teeny bit, what are some climate smart adaptation actions we can do in restoration? There's some great resources that go over climate adaptation and have all different kinds of ideas that I'm happy to share with you. Putting adaptation principles into practice is one free guide that's online and has a lot of amazing chapters on that. As well, Pacific RISC is going to be putting on a 2-hour workshop this summer at the Hawaii Conservation Conference, which I guess is later this month. It's coming up soon. We're going to be diving into that. So we're going to be looking at particular areas that land managers are interested in and trying to come up with climate smart adaptation actions that could be done in the face of both invasive species and climate change. As well, there are ideas you know, that are related to that come out in our management research summaries. I think it would be great as well for us to do a management challenge on that in the future. So that's those 2-page summaries. So there's lots of different things that can be done. And one more I'll point out is check out what's called the Resist, Accept, Direct framework, or the RAD framework. And it is a relatively new framework for how to think about what managers can do in the face of rapid global changes. And it proposes that managers can either resist those changes, which may not always be feasible, they can accept those changes, or they can try to direct system states in ways that are more favorable. And there's a lot of great ideas in those National Park Service publications about RAD, as well as a whole issue of bioscience that was dedicated to that subject. So happy to share out anything, just get in touch with me in the future.
So Joe, do you have another question?
Hi, Dr. Parsons. This is Jojo in Kauai High. And this portion that you were just talking about infrastructure, I was wondering, a couple of weeks ago, there was a fire just above the Kohala Ranch subdivision. It just kind of sprang up and like it usually does, but this one was a couple of weeks ago. I was wondering if you guys somehow, being on Oahu even, could talk with the Department of Transportation to see if we can get some alternative emergency road. In this case, you cannot go to Kohala, or you cannot come from Kohala in order to go work at the hotels and things like that. And you cannot reach the Kohala Ranch subdivision to use their roadway to get to the mountain road. So it's like you might as well turn around and go home, which is exactly what happened. So if you folks have some connection, to ask the Department of Transportation, the State Department of Transportation, to provide some type of alternative emergency road. And that would go with our water distribution as well in the Kailapa subdivision. If the Department of Transportation would allow bringing water from the harbor area, the Makai lots, commercial lots, across Ponokoa Gulch, so that the Kailapa subdivision will have water to fight fires. Because right now we are at capacity that the Kohala Ranch sells to our subdivision. So we're at capacity and going higher. but there's no alternative. So if we could connect to that line, which the harbor has to have water, at least we'll have enough in our subdivision to do something about fires. If you guys can do that, since you're on Oahu, thank you.
Auntie Jojo.
Go ahead,
sorry.
Lauren.
So Auntie Jojo, I think you bring up a really great point, is that the presentation, that Elliot presented, I think we can take all of this different information and contact those landowners. So really, and this is where really working with the Kailapa Community Association and the board, and going to the commission and saying, we really need to have that access road put into Kohala Ranch in order to connect to the mountain road, to have another way out. And I think also using this information, that we know that climate change and invasive species are a risk, for our whole island and for this area and these different threats of wildfires, and getting together as a community in the community association and talking to, Department of Transportation. So I think, Jojo, we should connect, you and I connect back with the community association, because you're bringing up really great points. And I also think we would have the backing of Hawaii Wildfire Management Organization, to support these concerns and trying to really drive this conversation to create action sooner than later.
Yeah, I got you. And we've already followed up on that. This is 2023. So we're looking at big things to happen. So we did go to the meeting. We did go and we're working with Hawaiian Homelands. We did go to the Community Association, which is their #1 priority, water. We did go to the Kohala Center because they're doing the watershed on the Queen Emma lands. Yes, we followed up on all of those that you just came up with. So the next step is the Department of Transportation, which we are on the advisory council and have been asking them. So to go from this island and communication that way, if we could have you guys, because you guys are on Oahu where all the leadership is, instead of an advisory council, you guys are right there. You can go down to the office or call them up, or, some support system, because we're working on this side on everything that we can think of. And yes, we did. Thank you for letting us know. That's why we did do all of that so far. So that's where we.
And Auntie Jojo, I think you bring up a really great point. And, Dr. Elliot, he's actually residing in Kona, even though he works through UH Manoa. So he's on island with us.
Oh, great. Okay. So can we get together and do something about the water then?
I'm happy to talk more about this as well. And I'm so glad you brought this up, because I just wanted to say really quick that, we can talk about all these heady ideas, but climate adaptation really just comes down to the very local scale and what are the problems and what can we do to fix them to help people. So I really appreciate you bringing it up. And I don't know anyone at the State Department of Transportation myself. It's possible folks on our core team might, so I'm happy to be a resource if I can.
Wonderful. Thank you.
Any other questions? Elliot, I have, I guess, just one final question, and maybe this is going to go into how you talked about having that session at the Hawaii Conservation Conference, which Michael and myself will be attending and be there. But, you talked about having the need for more research and gathering that data. And I really appreciate the fact that you're taking these scientific articles and trying to disseminate them out so that, you know, managers and the general public can have access to that information. But has there been any talk or a plan for really how do we get this information to our government officials in order to help activate change?
Yeah, that's an excellent question. You know, there are a lot of articles coming out of the Northeastern RISC right now. So that's the original one that started up in the Northeastern United States. And I recommend everyone go to check it out. They've done an incredible job of, you know, looking at policies, and they've shown that a lot of invasive species policies aren't proactive enough. They've even compared invasive species watch lists between states and found that they're very different. And so every state seems to be doing its own thing, and they're not really talking to each other about what these issues are. And it is a lot more challenging in Hawaii. You know, we can't look towards our southern neighbor and then ask ourselves, what can we do to keep out those species? So there's a huge role to play in having an effect on that transport mechanism, right? So how do invasive species get here? And it's by being transported here. And I moved to Hawaii in 2010, and I watched the Willy Willy Gall wasp have devastating impacts and then start to come back after the biocontrol was introduced. I watched the Nio, the native Nio decline to almost nothing in Pu'uwawa due to the Myoporum thrips. I saw rod start to have an impact and devastate, 100,000 acres of native forest on the Big Island. And these impacts are going to keep happening, and probably those impacts are going to accelerate in the future, given all of the things we talked about. So I think it's a really good question: is what are the policy levers that we can kind of work on that are going to make a difference? Part of that is a research question. I think part of that is trying to determine, where we can make the biggest difference. There's different ways to try to keep out invasive species. For example, you can have a list of species you won't let in, and that's what Hawaii has right now. And it's a pretty small, noxious, weed list, for example, and harmful predators. But you can also have the opposite of that. You can have a list of what you allow in. And so, as a state, I think Hawaii really needs to think about, what can we do in the face of these increasing impacts and pressures, and 10 years from now, are we going to have let in the next Willy Willy Gall wasp and thrips and rod and see even more devastating impacts and lose even more native species in forest over time, as well as, watershed recharge and all the things that we also care about for people. So, I would say we're, as an organization, Pacific RISC is not here to advocate for one policy over another, but we're trying to help build the conversations and get people talking about it. And as much as we can do that and fill that need, we're here for that.